So now we're going to take a look at solving exponential equations. And we were just, the video right before this one, we looked at graphing exponential functions. And I said that the way that we know we have an exponential function is that the variable is floating in the exponent spot. Well, the way we know we're going to solve an exponential equation is the variable is floating in the exponent spot. Now, from Algebra 1, we just know that, Algebra 1 and 2, we know that most of the time solving involves getting x alone, just x alone. Well, how can we get x alone if it's up floating, right? I need to get it by itself. Well, it's not even on the baseline. So we have a little trick that we use for solving exponential equations. Now, there's another trick that we use, and it involves logs, but we're just going to talk about the simple way to solve exponential equations. Okay, so here we go. I'm going to start off by giving you an illustration over here, that I think will make sense. If I say that 5 to the third power is equal to 5, and then I all of a sudden say to the x power, without any math knowledge whatsoever, what would you say is the value of the x? Well, of course you would say that it must be that x is 3. Because if these really are equal, then they would have to match. Everything about them would have to match, meaning the base would have to be raised to the third power on both sides, right? If this is going to be 5 to the third power, then this would have to be the same. Okay? So this concept here is what we're going to use to solve all of these problems that I have for us. Okay? So let's take a look. I have 3 to the x, but on the other side I see that I have a third, and I'm thinking I could turn that into 3 to some power, but I would have to use my knowledge of negative exponents. Well, again, if you haven't seen the video, a couple of videos previous to this, you need to go watch it, because if I take 3 and I raise it to the negative 1 power, then I get 1/3. And so if I can rewrite going the other direction, well, then I've solved this equation already. In other words, I'm just going to look at that and go, gosh, doesn't x have to be negative 1? So I'm going to go ahead and pull that down. Now, it's not that the 3's are canceling. There's none of that happening. It's just that I'm using my logic. It's just that I'm using logic, and it has to be that the exponent is a negative 1. And so there's my answer. Isn't that simple? Let's take a look at another one. Okay, so we're going to take a look at this one, and I'm looking for how I can make the bases to match, right? This is the whole idea. If I can get my bases to match on both sides, then I'm home free. So I don't have a 2. I look at this one and I think, gosh, I think that's just 2 to some power. And I'm correct, right? It's 2 to some power. Now, if I'm just thinking, see, that would be 8 times 2, 16. Oh my gosh, it's just 2 to the 5th power. So I'm going to rewrite that as 2 to the 5th power. Now, I didn't need any kind of special calculator for that. I'm just using my head. Now, can I get this left side to be 2 to some power? Well, certainly I can. I can rewrite it by going backwards and thinking about, excuse me, I can go ahead, I got to have the x there, right? Because that's really what's showing above. So I'm going to just rewrite that 1/2. Let me highlight that for us. The 1/2 is being rewritten as 2 to some power. Does that make sense? As 2 to some power. So what is the power that 1/2 should be? How should that be rewritten so that it really does equal, go back to 1/2? Well, it would have to be 2 to the negative 1. Right? 2 to the negative 1 means that 2 is sitting on the wrong side of the fraction line, and that would be that to the first power, which would be 1/2. And so this right here is this right here. Now, let me think back to my days in Algebra 1 and 2, and what is it that I do when I have a power raised to a power? Well, I'm supposed to multiply those powers, so let's go ahead and do that. I have 2 to the negative 1 to the x power. Well, negative 1 times x is negative x. Look there. Now, you see this right here? You see this in play? We know now that I can take the exponents and set them equal. Now solve the equation. It's not solved already like the other one was, but there's not a whole lot to do to that to get it solved. And there it is, x is negative 5. If you want to grab a graphing calculator and drop in the negative 5 in that position right there, if you put negative 5 in there, that's going to equal the same as 32. So you can go check it on your own. I'll let you do that. Number 3, let's take a look at that one. Now, I'm looking at these again in my goal because I see that x is floating. X is in the exponent spot. Exponent, right? I'm going to try to get my bases to match. Well, I'm not going to do anything to this left side. The base is already at 4, and I know that I can rewrite 64 as 4 times something. 4, that's 16. Oh, that's 3 times, right? So I'm going to go ahead and replace the 64 with 4 to the 3. All right, so, oops, excuse me, losing my microphone here. There we go. So I have 4 to the x minus 2, and I have 4 to the third. Now, whether there's a parentheses around that or not, it doesn't matter, right? It's just the exponent has an adjustment being made to it. So the bases are matching, right? These bases are good, so now I'm going to pull the exponents off, set them equal to each other, and I'm going to solve the equation. So I get plus 2 on both sides, and x is 5. If you wanted to, you could go ahead and take a look and check it. So let's see. If I put a 5 right back in there, right? I put a 5 there, that would be 4 to the third power, and that would be correct. All right, one last one. So let's take a look at this one. I'm looking at that and going, gosh, that's going to be pretty easy to get a 125 to be written as a 5 to some power. And if I think about it for a little bit, I go, oh, that's just 5 to the third power. Well, that one was pretty easy. Now, I just realized that I need to go ahead and solve for the x because it's not finished, and there's my answer. Not too bad, right? Okie doke. So I hope this was helpful. Thanks for watching.